everybody, Dr. Marty here, and we are now well on our way into our chapter number 6, which is on systems of equations. This is a situation where we're given two different equations for lines, and we want to try to solve to find a solution that satisfies both. So in section 6.1, we saw how to do that by graphing. Remember, we graphed two lines and we saw the point where they intersect. That was our solution. Well, there are a couple other ways which sometimes are a lot more convenient than graphing, especially because graphing can take a long time, for solving systems of equations. And the first one we're going to talk about is substitution. So this is how to solve systems of equations by substitution. With substitution, we're substituting one variable in the other equation. Okay, and you're going to see how that works right here. So step one is we're going to solve either equation for either x or y. Now you can do it for either one, whichever one's going to be easier to plug in. You're going to see how this works in a second. Step two is going to be to plug in the expression for the other variable. So let's say we solve for x, we plug in whatever we get for x into the other equation. You're going to solve for that first variable, then you're going to plug your answer into either equation to solve for the second variable. Finally, you're going to write your answer as a coordinate, which is x comma y. Now that's kind of vague and hard to understand if we're not doing it. So let's just jump in. We're going to do 4 examples, which are going to pretty clearly show you how to do this. Okay? Pretty clearly show you how to do this. So first one is going to be example 1. And we have y equals negative 2x plus 7 and 3x plus 2y equals 12. Okay? So y equals negative 2x plus 7 and 3x plus 2y equals 12. Well, step 1, if you look up above, was to solve either equation for x, either x or y. Well, conveniently, we've already got one here, right? This is solved for y. This is solved for y, okay? So that's our y here. And then we have the second equation, 3x plus 2y equals 12. Well, here's the y right here, all right? So what we're going to do is we're going to take this expression and plug it in right here. That's what we're going to end up doing. Okay, so we've got y equals negative 2x plus 7, so that means we can take y equals negative 2x plus 7, put that in for the y here, and we're going to be able to solve. So we have, I'm going to use another color to make this a little bit easier to see. I'm going to try to, at least for the first round, I'm going to show you what this looks like. So 3x plus 2 times, well, guess what? We've got negative 2x plus 7, so I'm going to make this purple, negative 2x plus 7 equals 12. Okay? Do you see how I did that? So we had y equals negative 2x plus 7. That plugs in for the y here. So we have 3x plus 2 times this, which is negative 2x plus 7 equals 12. Well, now all we have to do is solve for x. You'll see that we now have an equation that only has x as a variable. Okay? So step 3, above, we solve for either x or y. We already had it solved for y. We plugged what we had for y into the other. We're going to solve for the first variable, which is x. All right? So 3x plus 2 times negative 2x plus 7 equals 12. We're going to distribute here. So we get 3x. 2 times negative 2x is going to be negative 4x. Right? And then 2 times 7 is 14 equals 12. Does everybody see that? So we're going to get 3x minus 4x, which is negative 1x. I'll keep the 1 there, but it's really just negative x. Plus 14 equals 12. We've got to subtract 14 from both sides, right? Negative 1x equals negative 2. Everybody agree with that? Divide by negative 1. This cancels. Divide by negative 1. We get x equals 2. Okay? So we know that x equals 2. We know that x equals 2. All right? Well, now we can take this, that x equals 2, and we can plug it into either of these equations to solve for y. I'm going to do it in the first one, but you can do it in either one. So I'm going to come back to this first equation, right, which is y equals negative 2x plus 7, just because this is going to be an easy one to solve if we know the x. All right? And I'm going to plug this 2 in. For x. Okay? So I've got y equals negative 2 times 2 plus 7. I'm trying to use colors because I think it'll help you out a little bit. Okay, so let's solve that. Y equals negative 2 times 2 is negative 4 plus 7. Y equals 3. Well, guess what? Now we have a solution. Our solution is going to be x equals 2, y equals 3. See how that works? So what did we do? We solved for one variable. It was already there. Y equals this. We plugged that expression into this. So we had an equation that only had x in it. Solve for x, we get 2. Then we plug that 2 in to solve for y, and we get our x and our y value. All right, I'm going to do the same thing in example 2, but this time I'm not going to switch colors the whole time. All right, I'll just use one color, and I'll use green, just so we don't get confused. Okay, so we've got 2x plus 2y equals 12, and 3x plus 2y equals 12. Ooh, those look pretty similar. All right, so when I look at this, I am seeing that I'm going to solve one of these for y. Now, we can do this either way, but I think that'll just be the easy way of doing it. And I'm actually going to use color, now that I think about it, just to make your life a little bit easier. So I'm going to try to solve for y here. Okay? So what I need to do is I need to solve this for y. And then plug it in. Okay, I'm going to solve this first equation for y, and then I'm going to plug it in here. All right, so let's go ahead and do that. 2x plus 2y equals 12. I'm going to subtract 2x from both sides. I get 2y equals negative 2x plus 12. Divide by 2 all across the board. Remember, it's got to be everywhere. And I get y, these cancels, equals negative x, negative 1x, but negative x, right, plus 6. Now I've got something right here that I can plug into this equation. Okay? So I'm going to take the second equation. (3x plus 2y equals 12). And I'm going to plug this in here. So 3x plus 2 times the quantity negative x plus 6 equals 12. Sorry about the color thing. I wasn't going to use color, then I realized this is really going to help you see this a little bit more clearly, especially if you're not here in class when I'm doing this. So let's go ahead and solve. We're going to distribute 3x. 2 times negative x is going to be minus 2x. 2 times positive 6 is going to be plus 12 equals 12. All right? Combine like terms, we get x plus 12 equals 12. Subtract 12 from both sides, we get x equals 0. So now we have an x equals 0. Okay. I'm going to come back to this other equation, which was 2x plus 2y equals 12. And I'm going to take this x equals 0. I'm going to plug it in for x, because we know x equals 0. Okay? So we've got 2 times 0. It's kind of crazy when I have to switch pens so much. Right, 2 times 0 plus 2y equals 12. So this just becomes 0 plus 2y equals 12. So 2y equals 12. Divide by 2. Y equals 6. And that gives us our point, 0, 6. Okay, hope you can see all that somehow. That is how we solve for systems of equation by substitution. Okay, now we've got 2 more examples because it's important that we practice this a lot. So let's do this, and this first one's going to be pretty straightforward because we're already given 4y equals x, right? And we can just plug this in right here. So I'm going to do this without color. I'm going to plug that 4y in here. So I've got 3 times 4y, right? This 4y gets plugged in for x, minus y equals 66. Whoa, big number. Okay? 3 times 4y is 12y, minus y equals 66. 12y minus y is 11y. 11y equals 66. Divide by 11. This cancels. We get y equals 6. Okay? Y equals 6. We're going to go ahead and we're going to plug that in here. right? So we've got 4y equals x. I'm plugging this in here. So I get 4 times 6 equals x, or x equals 24. And that is our solution, 24, 6. Okay? Then final one. This one's a little bit more complicated. Example 4. It says negative 2x plus 5y equals 19, and 3x minus 4 equals y. Well, good news. Very good news. We already have got something solved for y. So we can just plug that right in. Okay? So negative 2x plus 5 times, right here I'm reading 3x minus 4, I'm not using the colors, equals 19. Equals 19. Okay, this is a little bit trickier. So we get distribute here. We get negative 2x plus 5 times 3x is 15x, minus 5 times negative 4 is 20, right? Minus 20 equals 19. Combine, we get 13x minus 20 equals 19. Add 20 to both sides. 13x equals 39. Divide by 13. And we get x equals 3. Now, and I'm going a little bit faster here. But I think you've got the hang of it, right? Once you have this set up, you should be able to solve through and solve an equation that just has one variable, right? Then let's just take one of our equations and plug that in. So we've got 3x minus 4 equals y. I'm going to plug this x equals 3 in here. So I've got 3 times 3 minus 4 equals y. 9 minus 4 equals y. 5 equals y. That gives us our solution, which is just 3, 5. So that is solving systems of equations by substitution. Okay, a review of the steps. Step 1, you're going to solve one of the equations for either x or y. You're going to plug that in, whatever the expression is, y equals something or x equals something, in for the other variable. You're going to solve for the first variable, plug your answer into either equation to solve for the second variable, and then write your answer as a coordinate x, y. Hope that helped. We'll be back with our next way of solving systems of equations, which is elimination, next time.